So this is a very quick introduction to the trigonometry that we started to cover in lessons last week. It does not include the full detail of everything that we looked at in lessons, but it should be a quick introduction to help everyone who missed those lessons get up to speed, ready for lessons next week. Now, it's really important that we start with a right-angled triangle. Now, in my right-angled triangle, I'm going to label this angle here as angle X. Now, when we're dealing with trigonometry, we're working with side lengths and angles in right-angled triangle, unlike in Pythagoras' theorem when we're working with the side lengths only. We must label the triangle in a very particular way when we're dealing with trigonometric problems, and this is really important. Start by labelling the hypotenuse. It's always the longest side in your right-angled triangle. It's always directly opposite the right angle. So that is this one. So we'll label that with an H for hypotenuse. The next side I would recommend labelling is the side that is directly opposite the angle of interest. Now that will make more sense when we actually start to look at a few problems. So I always advise people to start with the angle. You can see it here, it's labelled X in yellow very clearly. Imagine walking in an opposite direction to that angle and you will always hit the opposite side. So we'll label that with an O for opposite. That then leaves one side left unlabelled, and can you see that that side is next to the angle? It's touching the angle X, and so we call that side the adjacent, labelling it with an A. And the word adjacent is another word for next to, so that side is next to the angle, so we label it A, adjacent. This then allows us to introduce the three trigonometric ratios, or the three trigonometric formulae. Now, we went into much more detail about where these formulae came from in the lesson, but for the moment, we're just going to write them down. So, we know that the sine of the angle is equal to the opposite side divided by the hypotenuse. Now, what is sine? Sine is what we call a function. It does something to the value x, and it happens to be equal to the opposite side length divided by the hypotenuse side length for a right-angled triangle. Please be very clear, you're not doing sine times x. Sine is not a multiplier, it's a function. A little bit like when you square a value, that means you multiply it by itself or you do something to a value. Sine does something to the value x. Now what it does is well above the reach of year 9 maths, but for the moment you can think of the sine of the angle as being equal to the length of the opposite side divided by the length of the hypotenuse side. And you've seen that button on your calculator. You may have pronounced it as sin, but it is actually sine. Now, there are two other formulae as well. There's the cos of x, which is short for cosine, and that is equal to the adjacent side divided by the hypotenuse, and then the tan of x, which is equal to the opposite side divided by the adjacent. Now, to simplify our work, we sometimes put these in formula triangles. So sine, which is S, is equal to O divided by H, so that gives us the SO triangle. The cos of the angle is equal to A divided by H, so that is the Ca triangle. And then this leaves us with one final formula triangle for tan, which is the opposite divided by the adjacent, and that is the TOA triangle, T-O-A. Now, together, we sometimes identify these three results as SO, Ca, TOA. And it's just a a way that people sometimes memorise the three results, and we've got to memorise them. We've either got to learn the three formulae in orange or the three purple formulae triangles, which we're going to be using in the next few examples. So the first thing that we're going to do before we even actually perform any trigonometric calculations is to check that we can label the three sides of a right-angled triangle correctly. So let's look at each of these examples. We're going to do the first one together. So number one over here. Start by labelling the hypotenuse, the longest side. It's over here. Then track opposite from the labelled angle to give you the opposite side, and then the adjacent. Let's try the second triangle over here. So first thing, label the hypotenuse. It's directly opposite the right angle, so it's over here. Then walk in the opposite direction from your labelled angle, which gives you the opposite side, and then you're left with the adjacent, which is the last unlabelled side. You're now going to try the rest of these questions yourself. In each case, sketch the triangle, add in the right angle and the yellow labelled angle, and then label the hypotenuse, the opposite and the adjacent carefully. So pause the video, have a go at these, and then check in to see if your answers are correct. So question 3, this is the hypotenuse. This side here is the opposite, and this is the adjacent left over. Question 4, this one here is the hypotenuse. This one is the opposite, and this is the adjacent left over. Question 5, this is the hypotenuse. This is the opposite, and this is the adjacent. Question 6, this is the hypotenuse, this is the opposite, and this is the adjacent left over. So we're going to have a look at the simplest examples where we find the length of a side. So have a look at question number 1. We're going to calculate the length of the side marked X. Now, your first job is to make sure you identify the three sides. So the 12 centimetres is the hypotenuse, the X is the opposite, and then the blank side over here is the adjacent. Now, you are always going to be working with two of the three sides. One of the sides you'll be given the length of, which is the H over here, we know it's 12, and the other side will be the one that you are working out, which in this case is X. Now, remember those three SOHCAHTOA triangles, those formulae triangles we wrote down earlier? Here they are on the top right hand of the screen. Now, which of those is the only one that features an O and an H? And you should see that it's this one here. It's the triangle that says so. Now, the way the formula triangle works is you cover up the thing that you are trying to calculate. What are we trying to calculate? We want to calculate X, which of course is the opposite. So we cover up the opposite in the formula triangle, and it tells us that the opposite is equal to S multiplied by H, because that's what it means when two letters are next to each other in the formula triangle. What does the S actually stand for? It stands for sine of the angle, which in this case is 50 degrees. So we need to do sine 50 multiplied by the hypotenuse of 12. We're going to input this into our calculator, and this gives us an answer of 9.1925 ... So X is equal to this value here, which I'm going to round to one decimal place, 9.2. Now, if your calculator gives you a different answer, it's in the wrong mode and you need to reset it, so please speak to your teacher to ask about that. Let's try question 2. Can you label the three sides first of all? Start with the hypotenuse. It's the 20 centimetres. Which side is opposite the 32 degrees? It's this blank side. So what's left over? It's this side here, X, which is the adjacent. Now, let's highlight the two sides that we are interested in. We know what H is, it's 20. We're trying to find X, which is the adjacent, so we're not interested in O at all. In the first question, we weren't interested in A. So which of the three SOHCAHTOA triangles up here, they're all listed up here, which one features the A and the H. It's not the first one because that features O and H. It's not the third one because that features O and A. It's the middle one. It's the cap or the cos triangle, which features C, A and H. Now, cover up what you are trying to find. We are trying to find the adjacent, which is labelled X. So we cover up A. And the formula triangle tells us that C and H are next to each other, so A is equal to C multiplied by H. What does the C stand for? It stands for cos of the angle, 32, multiplied by the hypotenuse, which is 20. Input that into your calculator, and you find you get an answer of 16.960 ... Let's round that, and this gives us our value of X, which is 17.0 centimetres to 1 decimal place. Let's try one final example. Start by labelling the 3 sides as appropriate. Now, this blank side here is H. The opposite side, so the side that's opposite the 24 degrees, is labelled X, and this 6.4 is left over, so it's the adjacent. Which two are we interested in? We know the adjacent, it's 6.4. We're trying to find the opposite, it's X. So which SOHCAHTOA triangle features the O and the A? It will only be one of them. It's the TOA triangle. So let's fill in T, O and A. And which are we trying to calculate? We're trying to calculate this one here, O. So I cover that up. And then O is equal to T multiplied by A, but the T actually stands for tan of the angle, tan 24, multiplied by the adjacent 6.4, and we input this into our calculator, and this gives us 2.849 ... which is 2.8 centimetres to 1 decimal place. And we can solve any trigonometric problem very, very easily using these 3 trigonometric triangles. They are very, very important. They're not the only way we can solve trigonometric problems. There are other techniques as well, but this is one way in which we can work. So make sure you have those written down carefully, because we're going to do some practice questions now using the textbook. Before we do that, we're going to write down the key steps that you need to follow when solving a trigonometric problem. Now, the first thing you must make sure you do is label the hypotenuse, the opposite, and the adjacent in the right angle triangle. So that is the first thing that you must do. Once you've labelled the hypotenuse, the opposite, and the adjacent, circle or highlight the 2 sides that are relevant. Now, one of these will be the side you are given, or the side whose length you know, and the second of these will be the side you are trying to calculate. So you'll always be working with 2 out of the 3 values here. Once you've done that, you need to decide which of the 3 SOHCAHTOA triangles you need to use. So remember the 3 formulae triangles. I recommend writing them down on a post-it note and then moving that post-it note from page to page in your exercise book as you work on these questions. So when you're using the correct formula triangle, cover up the value that you are aiming to calculate. and then use your calculator to work out the missing value. You must make sure you've written down the notes on this slide very carefully so you have the key 4 steps here when you are solving a trigonometric problem. You're now going to have a go at doing this using the questions from the textbook. So you're going to start with exercise 3M, which is on page 252, questions 1 and question 2. Now, you must sketch each of the triangles and you must label the sides. So you need to label the H, the O and the A in that order. And then draw out the correct formula triangle and write down all your working. If in doubt, go back to the 3 examples that we did earlier in the video. You should have written down clear notes on each of these. Set your working out in exactly the same way. So for the first question here, in question 1, we need to label the hypotenuse, then the opposite, and then the adjacent. So make sure you have a sketch of each of these triangles in your exercise book as you do each question. Then label the H, the O and the A. Now, which 2 are the relevant sides? Well, we're trying to find out this one. So that's the opposite. And we've been given this one, which is the adjacent. So we then need to identify which of the 3 SOHCAHTOA triangles is relevant to us. Well, the SO triangle features O and H, not O and A. The CAH triangle features A and H. And this leaves us with the TOA triangle, which is the one that we want. So we don't want either one of these 2 in this particular question. Now, what are we trying to find? We're trying to find O, so cover it up. O is equal to T multiplied by A, which is tan 33, remember the T stands for tan, multiplied by A, which is equal to 5. And then if you work that out on your calculator, it gives you 3.247 ... Always do this step here where you write down your pre-answer before you write down your rounded answer, 3.2 centimetres to 1 decimal place. Or in the question, it does say 3 significant figures, so that would be 3.25 centimetres to 3 significant figures of rounding. So this is the level of working that I would expect to see. Now, sometimes people get a little bit ahead of themselves and think that they can do all of these questions without drawing the SOHCAHTOA triangles, without writing down all of this working here. We are only looking at the most basic questions at the moment. Trigonometry becomes by far more complex. If you start jumping steps now, you are going to start making a lot of mistakes, a lot of errors, and you will find it very difficult to answer the harder questions correctly later on. So do not skip any stages of working. You must show full, clear and detailed working for each of these questions. And again, go back to the layout of the 3 examples that we did if you need to get another idea of how to set out your work. And also, sometimes people suddenly assume that all the questions will involve multiplication. At the moment they have been. Later on, when we do some different examples, you will see that not all questions involve the multiplication. So that is why we need the formula triangles. That is why you need to show all of your working. So we've done part A in this question. Please try the other questions. The answers will come up in about a second, so make sure you pause the video, try all the questions, and then mark all of your work before moving on to question 2, please. So having completed question 1, please now complete question 2. Again, sketch every triangle, mark the H, the O and the A, write down the correct SOHCAHTOA triangle that you're going to use, cover up the letter that you're looking for, work out the calculation, showing and writing down all your working, and then check your answer. So the answer is going to pop up in a second. Make sure you pause the video, answer all the questions, then check your answers are correct. So here are the answers. Check that you've got everything correct. If not, please go back, try and identify where you may have gone wrong. some confusion does set in some of these questions, partly because of the labelling here, for instance. This side here is labelled as A, but that just means it's part A or question A. It's not the adjacent. So you should perhaps maybe label that as X to help you with your work. Same here. Sometimes in the past people have seen this and thought that it's the hypotenuse. It's not. So just label it X. They've just labelled it H to represent question H. So we're now going to have a look at a slightly different trigonometric problem. Different in the sense that the question will work in a different way to the other ones. Let's have a look at the question. So our job in this question is to find the value of the side length marked X. Now remember the stages. Label the three sides. So which one is the hypotenuse? It's directly opposite the right angle, so that's here. Which one is the opposite? Well, it's this one, and what's left over? It's the adjacent over here. Circle the two sides that are relevant to us. So we're trying to find the hypotenuse, and we've been given the opposite over here. So which is the SOHCAHTOA triangle that is relevant to us? So I'm going to make sure I have a careful look at my SOHCAHTOA triangles. So there's the sine one, there's the cos one, and there is the tan one. Now, which of these is the only one that features an O and an H? It's this one. So the other two, for the moment, are irrelevant to me. What am I trying to calculate? I'm trying to calculate H. So I cover it up. But this time, look at the formula triangle. There's no multiplication here. It's O divided by S. So H is O divided by S. But what is O? It's 5 centimetres. What does S stand for? It stands for sine of my angle. So I now need to do 5 divided by sine 45. So it's really important that we understand that trigonometry is not always about multiplication. It's sometimes about division. Now your calculator might give you an answer with a square root. So press the SD button to convert it to a decimal. So we have 7.071 ... or 7.07 to 3 significant figures. So how do you know whether to multiply or divide? It's all about what you cover up in your formula triangle. So for instance, if we're calculating O, we cover it up, it's S multiplied by H. If we were calculating H, however, and we cover it up, it's O divided by S. So how do you know whether to multiply or divide? You use your formula triangle carefully. Let's try another example just to make sure we've understood this fully. So here's another example. We're going to find the value of X. What is our first job? Our first job is to label the three sides of the triangle. So H, the hypotenuse, is over here. O, the opposite, is over here. And this leaves X, the adjacent, over here. Now, let's highlight the two key sides that we are trying to calculate, or that are relevant to us. So we've been given this information here, so we know the O, and we're trying to calculate this one over here, which is the adjacent. So go back to the three SOHCAHTOA triangles. Which one of these is the only one that features the information that that is relevant to us in this particular scenario? So which one of these features O and which one of these features A? The only formula triangle that does is this one here. So the other two are irrelevant to us for the moment for this particular question. Now we're trying to calculate the side marked X, which is the adjacent. So I cover it up. And what does the formula triangle tell me? It tells me the adjacent is equal to O divided by T. So that's 7 divided by tan, remember T stands for tan, 58. So what does that come to? That comes to a value of 4.3740 ... So 4.37 centimetres to 3 significant figures. So the whole process is pretty much the same. what do we start off by doing? We label the three sides in our sketch, H, O and A. Do it in that order, hypotenuse first, then the opposite, then the adjacent. Circle or highlight the two relevant sides. There'll be a side that you are looking to calculate and there'll be a side that you know the length of. So you're always circling 2 out of 3 from H, O and A. Now, find your formulae triangles, your SOHCAHTOA triangles. Only one of them will contain the two sides that are relevant to you. So you'll always only be working with one of these three. Cover up or cross out the one you are looking for, and then use the formula triangle to decide whether you need to multiply or whether you need to divide. The formula triangle will tell you how to do it. You then use your calculator and you must write down every single step of your working as shown here. You cannot skip these steps out. At the moment, we are still on the very basics of trigonometry. We study it again in years 10, 11, 12, and even 13. It gets much more complex. And if we don't absolutely nail the basics at the moment, it'll become very difficult to answer harder questions later on. So make sure you understand this. And you're going to practice some further questions on the next slide. So here are the questions from exercise 5M, page 257. You're doing question 1, all parts of this. Now, start by labelling each triangle. Be careful in the first one because you're trying to calculate this length here, which they have labelled A because it's question A or part A, but it is not the adjacent. It's actually the hypotenuse. This side here is the opposite, and this one here is the adjacent. So be very, very careful with that question. Don't get confused. Sketch each triangle, label H, O and A, circle the two that are relevant to you, write down the correct SOHCAHTOA or TOA triangle, cross out or cover up the part that you are looking for, and then use the formula triangle to help you complete the calculation, writing down every single step of your working as you have seen in every example that we have done so far. The answers are going to come up in a second, so pause the video, complete all these questions, and then check your answers carefully afterwards. So here are the answers. Check your work, make sure you've corrected any errors, and then ask if you are unsure. In our next lesson, we'll be looking at mixed problems, some which involve the multiplication, some which involve the division, and making sure we are fully confident as to which method we need to use.